Hi guys, good morning and happy Thursday. Um, Today we're going to be starting off by talking about prime numbers and composite numbers. So before we do so, let's talk a little bit about what each of those are. So remember, we know that prime numbers are numbers that have two factors. And those two factors are always 1 and the number itself. And I'll write this over here. We have composite numbers. Numbers have greater than two factors. So basically what that means is 1, the number itself, and at least something else besides 1 in itself. It could be 2, 3, 4, 5, whatever another number is besides 1 in itself. Now, when we've talked about primes and composites, we've talked about an easy way to find them is to use 4 prime numbers, 2, 3, 5, and 7. And we can do that as we find our prime numbers today. Now, basically 2 is multiples of 2. Any number that is a multiple of 2, except for just the number 2, is going to be a composite number because it's always going to have 1 itself and 2. Now, that means any even number will be composite except the number 2. Remember when we go to 3, we have that threes trick. Any multiple of 3, if we add the digits together, if we add the digits together, if that's a multiple of 3, then so is the number. Remember, multiples of 5 will end in 5 and 0. And remember, those multiples of 7 were the ones that are not multiples of 2, 3, or 5. And those numbers, I'll write them down over here, are 49, 77, and 91. Those are the trickiest numbers because they're only multiples of 7 and not of 2, 3, or 5. So they're a little harder to identify. All right, so we'll start by going over these, a couple of these as we go through. So I'm going to start with 45. I would ask myself, is 45 a multiple of 2? No, because it's an odd number. It ends in a 5. Is it a multiple of 3? Well, if I add those digits together, 4 plus 5, that gives me 9. And if 9 is a multiple of 3, 3, 6, 9, which it is, then so is 45. So that would make it a composite number because it has at least 3 factors. 1 itself, 45, and 3. And also 45, if we looked, is a multiple of 5 because it's counting by 5s. All right. Next number is 62. Is it a multiple of 2? It's an even number, so yes. So it has at least 3 factors, 1, 62, and 2. So I would say it's a composite number. Next, 17. Is it an even number? No, it's an odd number, so it's not a multiple of 2. Is it a multiple of 3? Well, 1 plus 7 equals 8. 8 is not a multiple of 3, so it's not a multiple of 3. Is it a multiple of 5? No, remember multiples of 5 end in 5 and 0. And is it one of these 3 multiples of 7 over here? No. So that means 17 is a prime number. And it only has 2 factors, 1 and 17. Now, I want you to go through and do that for all of the rest of these numbers. And remember, you're also, the directions also say to circle the evens. So go back and make sure you circle the even numbers as you're going through as well. All right, go to the next part down here. The next part says find the 7th term in each pattern below. Let me change colors. So when we're finding the 7th term, we're finding the 7th number. Now here, notice I have 1, 2, 3, 4. So I'm going to need 5, 6, 7, 3 more numbers. Now the first thing I notice here is that my pattern is going down, so it's decreasing. So I need to find by how much is it decreasing and how is it decreasing. So I know that from 75, I'm going to subtract 75 and 70. That's going to give me 5. And then I'm going to subtract 70 minus 64. I'm going to find that that's 6. And then I'm going to do 64 minus 57. And that's going to be 7. And I'm seeing a pattern here. I'm noticing that from here to here, it went down 5. From here to here, it went down 6. From here to here, it went down 7. Now we just have to figure out what's going to happen next. And we have to find 3 more numbers. Now, by that pattern, it looks like the next one is going to go down by 8. So I could literally just take 57 minus 8. Now notice I'm going to have to do that 3 more times because I need 3 more numbers. and think, are you going to subtract 8 every time? Well, no, because that's not going along with the pattern. So as we see patterns that are decreasing like this one, we just have to find out by how much are they decreasing. Sometimes they'll decrease by the same amount every time. Sometimes they'll decrease by different amounts. Sometimes when they decrease by really big pieces at a time, they're being divided. So that's something to think about as well. All right. So next question. Um, we have 3 3/4, 4 1/2, 5 1/4, and 6. Now I notice that I'm going up each time, increasing in my pattern. So I'm probably most likely adding or multiplying. So I notice I'm going from 3 3/4 to 4 1/2. Now, one thing I could do here is I could subtract those. I could use a little bit of logic as well. I know that if I had 3 3/4, which I do, and I know if I added a fourth to that, that would give me 3 4/4, which would be 4 wholes, which is kind of what I have here. Now, I would just need to add one more half to that. So if I took 4 plus a half, that would give me 4 1/2. So in total, I added a fourth and a half to that number. And if I have a fourth plus a half, that's the same as adding 3/4. So basically what I did from 3 3/4 to 4 1/2 was added 3/4. Let's see if the same thing happens from 4 1/2 to 5 1/4. So from 4 1/2 to 5, that would be adding a half. And from 5 to 5 1/4, that would be adding that extra fourth. So again, I added 3/4. And from 5 1/4 to 6, I added 3/4 to 5 1/4 to get to 6. So my rule then is adding 3/4. Now notice again, I'm going to need 3 more numbers here. So basically, you're going to have to add 3/4 3 times, which I think you can do. All right, let's go to the last question. It says Dayton Skywalker and Arthur Vader are bitter rivals. The only way to solve their problems is to have the biggest lightsaber battle of all time. During their battle, though, part of their lightsabers broke, so they decided to take a break to visit the discount lightsaber repair store of Tatooine. They had to pay $19.95 per lightsaber to get them fixed. So $19.95 per lightsaber. And remember that there's 2 of them. On the way out at the cash register, they also picked up 7 Skittles. That's bags of Skittles for 79 cents each. All right. For 79 cents each. If they paid with $100 bill, so $100 total is what they have. How much money do they have left? How much money do they have left? All right. So we know that they start with $100. We got to think about what they're buying. Well, we know that they are going to have to repair their lightsabers, and that comes at a cost of $19.95, and they're going to do that 2 times. So I'm going to multiply that by 2. If we're thinking about what else are they buying, well, they're buying 7 bags of Skittles for 79 cents each. So I'm going to multiply 79 cents times 7. Now, this is the total amount of money that they've spent. If I can find a total there by combining those amounts, all I then have to do is find the difference between that and what we started with, which was my original $100. I can do so, then I have answered that question of how much money do they have left. So think about how much they started with, how much they spent, and find the difference between them. All right, I think that's it for today. Really nice job, and I'll see you guys in class later.